Hi, this is a video on circular functions or trig functions. We're looking at exact values today, and hopefully this will be less than 5 minutes. Learning intentions: know how to find exact values for angles in the first quadrant for sine, cos and tan. Know how to find exact values for positive and negative angles from other quadrants for sine, cos and tan. And know how to solve problems of the form evaluate sine of negative pi on 3 minus cos 5 pi on 4. First things then, first quadrant angles. This is the exact value table and the cast diagram that's provided on your formula sheet. These are the ones that we'll be using. Now, we've already looked at how to prove what all of these values are, so from now on we'll just be going to that table to look them up. So, for example, sine of pi on 6. This is a first quadrant angle. By first quadrant I mean between 0 and a half pi. Now, a sixth of pi is smaller than a half pi, so we're only looking about there. Sine of pi on 6 would be here. Now you can look that up straight away and say equals a half. Just like this, cos of pi on 3 would also be a half, and tan of pi on 4 would be 1. As I said, we've already looked at where these all come from, so we're just going to assume that's all okay, and we'll be looking at the table here. So, some more complicated ones, larger angles and negative angles. So the first one we'll look at is sine of 11 pi on 6. There we go. Now, sine of 11 pi on 6, that's almost 12 over 6 pi. 12 over 6 pi would take us all the way around, obviously 12 over 6 would be 2. So if we go from 0 to pi on 2 to pi to 3 over 2 pi, it would take us all the way around from here and almost to there, but not quite. We would be a sixth pi short. So that angle there would be pi on 6. You can think of this as being sine of 2 pi minus pi on 6. So 2 pi would be all the way around, so 0 or 2 pi there. Pi on 6 short, and we're looking at sine, which is the height of the triangle in the unit cycle there, in the unit circle. And you can see straight away that's going to be negative. It's below the axis there. And you can confirm that using your cast diagram. This is telling us that only cosine is positive in the fourth quadrant. Now, using the symmetries here, we want to take this back to the first quadrant. So we can create an identical triangle there in the first quadrant, pi on 6, pi on 6. So the height there would be the same value here, the same magnitude, except we know this is going to be negative. So, sine of 11 over 6 pi is equal to negative sine of pi on 6. Look it up in your table. Sine of pi on 6 is a half, so our final answer is a half. These are the 3 lines of working I'm asking you to show. Write down the original thing that you're trying to find. In your next line, you should indicate the sign. You don't have to write a plus if it's positive, so just negative if it's negative. And then the equivalent first quadrant angle. And then look it up in your table to write your final answer. Okay, now pause the video and try and do cos of negative 2 pi on 3 and tan of negative 11 pi on 4. Cos of negative 2 over 3 pi then would take me from 0 this direction, 2/3 of the way towards pi, leaving me with a quarter pi or pi on, sorry, a third pi or pi on 3 here. Equivalent first quadrant angle pi on 3. Cosine in the third quadrant is negative, as we can see here anyway. It's negative, but also your cast diagram tells you only tan is positive. So this is equal to negative cosine of pi on 3, which is negative, cosine of pi on 3 is a half, so negative half. There's an interesting one, tan of negative pi, 11 pi on 4 would take us from 0 going in this direction, because it's negative, all the way around for 8 over 4 pi or 2 pi, and then another 3 that way. So it's 3/4 of the way round, leaving our angle there as pi on 4. Equivalent first quadrant angle would of course then be pi on 4. It's tan, we can see in the third quadrant that's positive. So a couple of ways we could write this. You could say tan of negative 11 pi on 4 was the same as negative 3 pi on 4, because we just get rid of that 2 pi going all the way around. Then from that place there we can say it's the same as positive tan pi on 4. Oops. Pi on 4. There we go. Again, look it up in your table. Tan of pi on 4 is 1. So there's 1. So we've actually got 4 lines of working there. But what I'm after in every case is some diagram to show me what you're thinking and where this working comes from, and then these 3, or in this case 4 lines of working. Okay, I was really trying to get this under 5 minutes. We're up to 6. See if you can work this out, pause it, and then come back, and I'll just show a quick solution in a couple of seconds. Okay, so for this one, sine of negative 3 pi on 2, you can see is the same there as sine of pi on 2. So we can look that straight up in our table there. Cos of 2 pi, we can get straight, sorry, that way around, we can get straight from our table here. And tan of negative 11 pi on 6, so negative 11, almost 12, so almost 2 pi, leaves us pi on 6 here. Meaning we can just look it up straight in our table, which is root 3 on 3. That's first quadrant, and they're all positive here. So, root 3 on 3, meaning this whole thing is 1 plus 1 minus root 3 on 3, or 2 minus root 3 on 3, or 6 minus root 3 on 3. Either one of those would be fine. Okay, final bit then. Quick recap. Just always please draw a diagram, a unit circle or cast a diagram, and just indicate which direction you're going and how far you've gone. Stick your line in and use that to find that first quadrant angle. Identify the sine and the first quadrant angle and show those 3 lines of working. Your original line, the original equal to something else, which has both the sine plus, well, minus if it's negative, nothing if it's positive, and the cos, sine or tan of the first quadrant angle, and then your final answer. Okay, if you're not sure about any of this still, please go back through the video and just try and work them out one at a time. Pause the video. There we go, 8 minutes, not too bad.